Hello everyone, reporting today for Fun Robotics. I'm Abhas, and with me here is Team 16917, the Gear Wizards from Otsego, Minnesota. They have been absolutely insane this season. I've been wanting to interview them pretty much since Into the Deep started, but they only just competed, and we wanted to see how they did. Needless to say, they were second after their qualifications in total OPR, in teleop OPR, just all around. Absolutely amazing team. I can't wait to jump into this robot on Fun Robotics. Alright guys, so I guess my first question for you is just your general approach to the game and robot archetype. It's definitely one of the more unique robots, I would say, or just the way you guys have executed everything. So what was the decision behind no transfer and the pivoting slides and all of that stuff?
Yeah, so last year we competed at MTI, and our robot was super duper complex and had a lot of issues when we were there. So we made it a goal this season to keep it as simple as possible so that we could keep it working throughout the day in most of our matches. And then decided on the pivot archetype right on kickoff, about an hour afterward. We got right into prototyping because we decided on it as a really good way to keep it simple and no transfer, while also being able to reach far inside the submersible and get samples in the basket.
Sure, and so talking about the timeline a little bit, I feel like I've seen your robot just, come running out of the gate since very long ago, maybe late September, early October, something like that. So can you talk a little bit about that development timeline and how your robot has progressed so far throughout the season?
Yeah, so on kickoff, we started off with fully 3D printing a robot. So we had a completely 3D printed chassis that we tested the pivot structure on. That gave us about a week or two of testing, and then we have in-house machining. So right after that, we moved straight into making the final product for our qualifiers, and yeah.
Awesome, yeah, and so pretty much would you say last 2-3 weeks has been driver practice? A little bit more than that, a little bit less? Talk through that.
So we've actually had this robot fully running with hardware since the end of September. So since then, we've just been doing drive practice and autonomous.
Wow, awesome. So now jumping into your drivetrain, I don't want to spend too much time here, but I know one thing is I feel like I definitely saw a swerve out of you guys early, over the summer, early in the season. Obviously, this is not the swerve, so what was the decision behind not running that and, just the overall drivetrain that you did choose?
So we did do swerve because we thought it'd be a really fun summer goal, create a complex swerve, see how it turned out. It was fast and it was a little bigger than we thought it would be. And we decided to stick with the mechanism because we know it works. We know we don't have to troubleshoot it a lot. And then the swerve, we just don't want to spend the whole season on it.
Yeah, of course. And so now just talking about packaging a little bit, can we see what that looks like underneath the robot? Were there any special considerations you think teams could take into account and benefit from? Talk about that.
So we kept our robot at a light 22 pounds this year for the full chassis and everything. So we moved all 7 of our motors into the drivetrain here, and then there's 2 behind the channel. So that keeps our center of gravity super low, and it's actually one of the only major sources of weight on the robot, and we keep it at the very bottom of the robot.
And so you're looking at a 13.7 to 1 drivetrain, or a little bit slower or faster? Okay.
So we're running 1-to-1 435 RPM motors with the old 96 millimeter mechanism wheels.
Is that something you think you'll upgrade in the future or don't need to?
If we redesign the robot, we'll upgrade to the new Group Force ones for the acceleration. But we just stuck with the 96 because we had them in hand and we could start prototyping right away instead of waiting for those to arrive and redesigning it for bigger wheels.
Absolutely. So now jumping into your claw. Obviously, you guys have the capability to design an active intake. That's no secret, but why stick with that claw design? Yeah.
So when we were testing the claw, we actually started out with testing intake and claw, but when we were testing, the really compacted samples did not fare well with an intake because you couldn't pull one out of there reliably. And we ended up with the claw we did because it has the geometry in here to pull just one specific sample out, and we can grab it at any orientation inside the submersible. So that was really powerful for us, and especially when we're trying to get fast cycling.
Okay, awesome. Yeah, and talking a little bit about the design of the claw and maybe going a little bit further into the robot with the arm. So I see at least one servo for the claw. Is that a micro or a mini or something entirely different?
So we used a Axon Mini for the
Okay.
claw, as well as custom-made arms that have the 3D printed gear, and then we
Hmm.
designed it around a just one of the Go Build a Slim quad block mounts to keep the actual frame of it super strong, and then make it so we could 3D print it for future iterations. And then our arm was machined at the qualifier. We already started iterating on it for our next qualifier, but the basics of it is just two Axon Minis with 30 to 48 drive, and then that just drives the whole arm with a wrist servo here to control the pitch.
Awesome. Yeah, and so talking a little bit about sensors, I saw that limelight tucked away in the robot, and I was honestly very surprised about that because I had no idea it was there. So what do you use it for? Yeah.
So we use the limelight in autonomous and teleop because it's really hard to see when we're grabbing samples off the ground in the front here.
Hmm.
So the limelight helps keep the robot oriented as well as the claw pitch, because that way in auto, especially with the specimen on the floor, it really helped keep the specimen from falling when we drive into them, and it accounted for the odometry position loss.
So talking about like the workflow there, what exactly goes on, right? Like in a cycle, you're going into the human player zone, you're about to pick up a specimen. How do all of those components come together?
Yeah, so the arm just goes down after the last cycle,
Mhm.
and then we drive in at a certain position, and then this drops right when we know we've orientation locked on the specimen.
Mhm.
And then we use pager pathing, so we just hold a simple hold to whatever the limelight area is, and that holds a really exact position on where the specimen is.
Awesome. Yeah. So now jumping in a little bit into your slides and your pitching slides, walk us through that linkage mechanism and touch on any like difficulties you've had throughout the season with it.
So we again we wanted to keep the motors low in the chassis, so we geared it to the linkage, and the linkage is driven at this one arm here, and then we have custom machine standoffs here that control the other side, and then it's fully aluminum, and then the linkage is just try and repeat until it was perfect.
Mhm.
So it over centers at the sample dropping position at vertical, so that
Mhm.
way this acts as if it's locked when we're driving, which creates a no bounce, which is why we stuck with the linkage, as well as being able to hard stop it against the frame of the robot at the submersible position to keep it super reliable for the
Mhm.
submersible.
And so, yeah, I've wondered throughout the season why you don't angle your slides more during depositing, either for the basket or for specimens, when you do put them up on the rugs. Is that just so you can take advantage of that over center feature, or your slides, you don't have the length for that, or some other reason?
So the robot is so light that we prioritize the drivetrain speed more than these slides
Hmm.
because we only have one motor on this, so it can be a little inconsistent with the battery voltages.
Okay.
As well as having the hard stops makes it super reliable, and the drivers can account for where they know it's going to be instead of
Hmm.
where we hope it's going to be.
Yeah, that makes perfect sense. And so you said 7 motors. That's two for the pitch, one for the slides, or the other way around, or one for hang, one for pitch, one for slides.
So we kept one with the pivot because the pivot can be pretty high torque, low
Hmm.
RPM. And then we stuck with 2 motors for the slides. That way we could achieve the super fast slide movement.
Hmm.
So because for samples, you gotta go from the floor to the basket really quick. So
Hmm.
we kept with two 1150s for that with 20 millimeter spools. And then those are belted from the inside of the drivetrain. And then we just kept with 4 for the drivetrain, and then we have no motors on our hang.
Okay.
We to keep that servo driven. So there's Axon Minis with gears and spools inside of here. That way we can dynamically change how much it's pulling, as well as do a level 3 if we want to, which we
Okay.
were earlier.
Yeah, and so now going on to the hang, I think I've seen maybe a couple different hangs out of you guys, or I think I saw one that was definitely like machined, and then this one looks a little bit different. So have you tried different hanging strategies, and they just like some didn't work, some did work? Touch on that.
So we kept prototyping our hang while we were doing our scoring, just because it was a low priority part of the match. So we used to have hooks on the front here. That's what we started out with. They worked well, but they put a lot of stress on our slides, and we didn't want that to break. So instead, we moved it to a one-time mechanism for the end of teleop. So
Hmm.
we just have time-based servo movements to drive out our doing printed arms. So these hard stop, and then the rotating hooks latch on the bars, and then they just climb it up. And then the more force that's on the hooks, the harder it grabs, so it can't physically fall.
Yeah, that makes a ton of sense. Now, talking a little bit about game strategy and driving, you guys are probably one of the most experienced teams this season as far as driver practice goes. What do you think are some of the biggest shifts you've noticed in your driver strategy and just overall approach to the game as you've practiced more?
Yeah, so we try to, this year especially, we try to keep away from some of the other robots, especially the other lines. That way we can focus on scoring our one goal during the match. And then our drivers also, we don't change the slide position when we're cycling in the submersible, because that way the drivers can just back up and grab it immediately instead of doing some sort of slide thing and hoping that's there. That definitely helps, as well as just, we do hours and hours of drive practice. We have at least an hour and a half a night. And that makes sure that the robot and the drivers perform like synchronously, and we know exactly what's going to happen. And then we can also iron out any issues that we might have with the robot.
Yeah, absolutely. I mean, every single one of those things is such a valuable nugget of information for teams, and it'll really help level up their driving game. And so I know from the video, I think you guys posted like a 235 back-to-back or something like that. From that, you were definitely focusing on those samples a lot more, right? And just putting them in the basket back and forth. Is that also what you prefer to do in match? Do you practice a lot on specimen? Talk about that.
We do a lot of both. Our robot is very, we like the superstructure because it's very specific on doing both of those tasks. Because we can cycle getting the colors out of the submersible and putting them in the human player. And then the last minute of the match, we just, ring them up on the bar. And we do a practice. We alternate every night between specimen and sample practice. That way, if especially a lot of teams this year prioritize doing the basket because it's a little bit more less precise. And we found that with most teams that we play with, it's much more common that they can't do specimen and they can do samples. So we try to keep that high in priority so that we can partner well.
Yeah. Amazing. And so, looking forward, you guys have obviously taken this robot very far. Do you think you want to keep, do you think this is the robot design you envision yourself ending into the deep with, or do you think there are just some major changes that need to be made to really keep it competitive for the rest of the season?
Definitely depends on the competitions we're attending. Just for reliability and making sure the robot is, performing well at some of the closer competitions, considering, our second qualifier at Hermantown and our state competition in Minnesota, we probably will end up keeping the same structure and just iterating on the arm and the claw more. If we go to a higher level competition, we have more time to maybe implement a new design or separate slides. So
absolutely, yeah. Gear Wizards, thank you guys so much. I can't wait to see the match videos of your guys' competition. I mean, your practice is just incredible. The robot as a whole is so simple yet effective. I think you guys are really one of the best teams so far this season for sure, and I can't wait to see how you continue and into the deep. So thank you so much for reporting for Fun Robotics. I'm Abhas, and this is Team 16917, the Gear Wizards.